Graphical analysis is the third phase of data after descriptive statistics. There are many different graphs that we can use to draw pictures of our data. Each graph has unique communication skills, but it's all based on the type of data that we have. Will determine what type of graph we can use. A box and whisker plot is a very powerful data to compare multiple things. The anatomy of a box and whisker plot is based on the percentiles of data that you have. So the first percentile at the bottom part, or the bottom whisker, represents 25% of your data points. So 1/4 of your observations are represented with the length of that whisker. The next 25% of your data is represented by the bottom half of the box. The median is the line that splits the box. Be very careful with that, because a lot of students confuse the mean with the median there. It is the median because, again, the median has 50% of the data points below it and 50% of the data points above it. This follows, these percentiles follow with the upper half of the box being the next 25%, and then the upper whisker being the top 25% of observations. Outliers can also be easily displayed on a box and whisker plot. Here's an example of a box and whisker plot. You can see that the variation in numbers 1 and 2 are much greater than the variation in box 3. You can also see that the variation of the first 25% of data points in box 1, which is the bottom whisker, is much less than the first 25% of data points in the second box, which is the bottom, represented by the bottom whisker as well. But the range of box 1, the range of sample 1 is nearly the same as the range of sample 2. The location of that distribution is very different and demonstrated very well with the box and whisker plot. Histograms are another way that we can show the distribution of our data. The bell-shaped or normal distribution is in the upper left. A bimodal distribution, or double-peaked, is next to that, to the right of it, that shows two peaks. Skewed data we'll talk a little bit more in depth on. Truncated data, there has to be some sort of reasoning why data points stop at a certain point, and then the ragged plateau is a more random distribution.